All right. So great introduction to Kubeflow. This was exactly the background I needed to present my my presentation. So hello everyone, Stefano here. In this talk, I will cover basically all of the high-level features that Kale provides. If you already are familiar with Kale, you might remember that Kale allows you to convert Jupyter Notebooks into Kubeflow pipelines. But you will see during this presentation that there's a lot more to cover, since in the recent months, we've developed tons of new interesting features in our Recto. They haven't yet found their way into the open source repository, but they will soon. So let's get started. We will cover a bunch of topics, starting from how to convert notebooks into pipelines, and then how to do exactly that with plain Python code using the Kale SDK, how to automate creating and monitoring hyperparameter tuning jobs, serving models, and then how to do AutoML. We'll see in a bit what this actually means, and then how to do distributed training. So as Jimmy mentioned, Kubeflow is a collection of several components. It's not just a single monolithic software, but it's a collection of components that are supposed to interact with one another. These components go from pipelines that allow to orchestrate containerized steps into complex workflows, to hyperparameter tuning components, metadata, serving, as in KF serving, a bunch of training operators, notebooks, and so on and so forth. So in general, there exists documentation, examples, and tutorials on how to leverage each one of these components alone. But there's a lack in libraries and really examples and workflows that connect together all of these components. And Kale tries to do exactly that. It tries to be the connecting tissue among all of the Kubeflow components, providing simple to use high-level APIs that allow you to construct and orchestrate workflows that span across all of these different components. So let's start from notebooks. In vanilla Kubeflow, you would generally, in order to create a pipeline, you would generally write some machine learning code in a Jupyter notebook, and then you would need to go through the process of creating Docker images, writing some specific Python code using the Kubeflow Pipelines SDK to then convert all of these Docker images into a proper pipeline. So what Kale first introduced a couple of years ago was the notion of converting a Jupyter notebook into a pipeline in a seamless way, just by clicking a single button. So what we did there was to allow you to tag notebook cells using UI components, and then using some processing and some Python magic to unpack the notebook into multiple standalone components and have them translated into a pipeline. So you can see it in the right here, a notebook with multiple cells, just by means of tagging a few cells, can be converted into a pipeline that even has parallel steps. Now, the benefits of running pipelines from notebooks are several, starting from the fact that in general, you want your data science code to be well organized in the various business logic pieces of your project. For example, you start from data processing, feature engineering, training, serving. All of these pieces of code need to be in some sense separated between one another. And reasoning in terms of steps and components helps to do exactly that. Also, dividing, so unpacking and converting a notebook into a pipeline helps with data versioning, caching, and to run all of these steps and components based on their different hardware requirements. It could be that you want to run data processing, feature engineering on plain CPU-based cluster nodes, and then have the training process instead run in a GPU-based node. So this is to make cost efficiency. Now, reiterating on the previous concept, before using a Jupyter notebook to convert a notebook into a pipeline, what you would need to do is to write your machine learning code, create Docker images, write the KFPDSL code, compile, upload, and run the pipeline. Every new iteration would require you to go through all the way from the top to creating Docker images at every new change in the code. So create Docker images, upload them to your registry, compile again the pipeline, run it again. But with Kale, this all becomes easier since you just need to write your machine learning code in a notebook, tag it, and with the click of a button, always convert the notebook into a new pipeline. You need to amend the code, just go back to your notebook, click the button again, and you're done. Also, just a mention on how Kale integrates with ROC, or Ricto's data management platform. Since Kale can orchestrate all of these steps on its own, it also takes snapshots at each step of the way. And in this fashion, every step becomes reproducible because it is backed by an immutable snapshot. What this means is that whenever you need to go back in time, debug failing steps, or just introspect whatever your code was doing on the underlying data or whatever, you can just click on the step and redeploy a new notebook based on the state of the data and the code at that point in time. Okay, so enough with the notebooks. Let's talk about how to actually orchestrate plain Python code. Because let's be honest, working with notebooks is great, but when you want to scale, when you want to version your code, work in a collaborative manner, you usually want to work with plain Python, source code, modules, libraries, and it's not always easy to convert plain Python into something that can be actually orchestrated by something that runs on Kubernetes. So when we started to build the Kale SDK, our design principle was exactly this: to allow you to take your Python code as it is without having to change anything, and be able to orchestrate it by adding just a few lines of code. For example, okay, in general, just as you would do in a notebook, like dividing different parts of your project in different, let's say, parts of the notebooks. In general, you write functions targeted at machine learning tasks as separate components because you want to reuse your code, you want to simplify maintainability, and then it becomes natural to just write functions that have very specific very specific functions. For example, here we see a loading function that loads some data, splitting, training, all of this lends itself very well to be combined in yet another Python function that kind of orchestrates these different functionalities. So since this already is the way in general that people write data science code, then it just became natural to treat them as components and pipelines. Instead of having to learn a very specific SDK to create components, objects, compose them together, pass data around, we just infused all of the Kale magic that we use in the notebook for data passing, creating standalone components and pipelines into these decorators. So all you need to transition from local Python functions to a scalable and parallelizable KFP pipeline is just two decorators, step and pipeline. Moreover, the SDK, through the use of these decorators, supports pipeline metrics, Kubeflow pipeline parameters, metrics, artifacts, configuring Kubernetes metadata like limits, resources, node affinities, really whatever. And also, the SDK supports the conditional statements as plain if Python statements. So whatever if statement you place in your pipeline function, it will be converted into something that into a conditional operation at the pipeline level. This is very useful when you want to run steps conditionally on the results of other steps or conditionally on the pipeline parameters that triggered that specific pipeline run. And in the next few months, we'll also support for loops that will be very handy in cases when certain steps produce a list of results and you want a certain component to loop through those results. A very interesting feature that we've just finalized and you'll be able to find in our documentation is the ability to mingle Python-based steps, like what you see now, with container steps. So you can write Python functions, define them as Kale steps with the step decorator, and then place in the middle just a random container that you might have already built that runs Go binaries, C binaries, whatever, and have Kale still be able to pass data from the function steps to the container steps seamlessly. Okay, so now that we know how to build pipelines seamlessly from notebooks and plain Python code, we might want to up our game and actually run these pipelines in a distributed way using hyperparameter tuning. Katib is the hyperparameter tuner, the component of Kubeflow, which means that it's a component that is able to suggest points in a hyperparameter space based on a certain search, say, on a certain optimization algorithm and a certain optimization metric. So there was no way of orchestrating a hyperparameter tuning search where each computation unit is an actual pipeline. So that's what we did with Kale. We bridged the gap between running pipelines and running hyperparameter tuning jobs. And you can actually do this both from the notebook and from plain Python with the SDK. From the notebook is as easy as defining a pipeline as you would do with cell tags, adding pipeline parameters and pipeline metrics. And then with a very simple to use UI dialog, you configure the pipeline parameters, the search spaces, click a button, and Kale triggers a whole hyperparameter tuning job that works over pipelines. We have a very detailed tutorial that goes through this example, and I'll provide the link in the last slide of the presentation. what you do instead from the SDK would be to define the kind of search space you want the HP tuning job to optimize for in Python code. On the left, you can see how to do that with the Katib SDK. It looks a bit complex, but once you look at it, it's really not. It's just a bunch of objects from the Katib SDK that describe the objective, the parameters, and really how you want the HP tuning job to behave. And all you need to do is to feed this object you see on the right in the pipeline decorator. And if you start the pipeline like that, then Kale will take care of, instead of running a single pipeline, orchestrating a full hyperparameter tuning job. This is a screenshot from the Katib UI that actually some of my colleagues at Aricto have contributed to Kubeflow 1.3. This is the result of a hyperparameter tuning job that was created by Kale, and each one of these lines represents the performance of one of the pipelines that had been triggered based on one of the combinations of pipeline parameters suggested by Katib, while Kale stays in the middle to bridge this gap, to take the pipeline parameters suggested by Katib and spinning up pipelines, reporting back the results to Katib. Now, to close the loop, there's also serving. So Kale allows you to serve in-memory models just from a very simple to use Python API. You provide the model, optionally a processing function, and with just this single call, Kale orchestrates the inference service CR, which is the CR that KF serving provides to deploy models. And then from the resulting object, you can just provide some data and get back prediction. It's that simple. Just one single API call, feed it your in-memory model that you might have trained in the previous step, serve it, and then predict. So we've seen how we can actually greatly simplify building pipelines, running hyperparameter tuning jobs, serving models. And if you place them together, you can actually realize how these are all the components that in general you need for a successful data science workflow. So it's easy to imagine, let's say, placing them together and orchestrating them in an automated fashion. So let's walk through what the ideal process would be. You start from a Jupyter notebook, you convert a notebook or plain Python to a compiled pipeline, and then this pipeline gets orchestrated as a hyperparameter tuning job, maybe to find the best combination of parameters that train the best performing model. And then once that's done, automatically getting the best performing model, serving it, and getting prediction, all while backing all of these steps by submitting MLMD artifacts to trace the execution and all the relevant information at each point in time, like data sets, metrics, optimization values, or really whatever is needed to create a lineage of this workflow. And also having everything backed by reproducible PVCs, especially with rock snapshots. Taking this all together and creating an automated workflow led us to implement what we call AutoML. So we've introduced AutoML, I believe, about 6 months ago. we've released a tutorial that you'll be able to explore and go through. So for us, AutoML is the process of letting Kale really automate end-to-end everything that you've seen until now. AutoML is about providing you a single Python API that accepts a data set and a goal that can be a metric and a desired value. Then Kale goes through the process of generating suggestions, models, training them, working through hyperparameter tuning, getting the best results, and then serving the best resulting models for you to then validate, all in an automated fashion, just starting from a single API call. And actually, you can see this running live by going through one of our tutorials. I'll mention where you can find it in the end. Now, one very interesting API that we've built recently is the distribute API. So the missing piece between all of the Kubeflow components was actually running distributed training. And we wanted Kale to be able to orchestrate that as well. So we started with PyTorch, and we've built a single Python API that allows you to just provide a model, a data loader, and some other objects like optimizers. If you're familiar with distributed deep learning, then all of these things will be familiar for you. If not, all you need to know is that they basically are basically PyTorch objects that are needed for the training process to happen. So just by calling this distribute API, which is part of the Kale library, Kale orchestrates the creation of a new PyTorch job CR, which is the CR that actually describes a distributed PyTorch job that the PyTorch controller then uses to actually start and monitor the PyTorch job. And with this API, you are able to stream logs that are coming from the distributed training process, manage the PyTorch job CR, save the trained model, all in a very simple to use high-level API. You can use it from a notebook or as part of a pipeline step. So we've talked about how to convert notebooks from notebooks and pipeline plain Python source code into pipelines, and how to run hyperparameter tuning jobs, how to serve models, how to distribute deep learning training operations, how everything can be fit together in a single automated workflow that is AutoML. But we still got a lot of work to do, and we want to improve the existing APIs, support more distributed frameworks like TensorFlow, have a tighter integration with MLMD so that you're able to submit arbitrary artifacts, serve any kind of model from any model artifact submitted to MLMD, tighter integration with serving, so supporting more frameworks and more ways to serve models from the notebook, from pipeline steps, and integrating with feature stores, because we know that being able to handle features like with components like Feast is a very important feature for data scientists. And then being able to build standalone and reproducible Kubeflow Pipelines components starting from plain functions. So we will be working in the next months on all of these features, and you will see updates in our docs in our tutorials, and in future meetups. So Kubeflow Kale is an open source project. Many of the features that you've seen now have not yet found their way into the open source repository, but they will very soon in the next few months. Still, you are able to test this out using MiniKF. That is our portable and one-click solution, Kubeflow solution that works across any cloud or in your local PC. So all of our tutorials and code labs work perfectly well on MiniKF. That can be your test environment and playground. So here are some links. I guess we'll share the slides afterwards, so you don't have to rush and copy them. We're also recording this session. So anyway, by accessing the Aricto website, you basically can find yourself all of these pages, from the tutorials to the Get Started guide, the Kale docs, and the community resources. Okay, that's about it.